Hello everyone, I'm Valerio Benedetto from the MIDAS Theme, and today in this video I will talk about inferential statistics. In particular, I will provide a brief introduction to hypothesis testing and common inferential tests. First of all, I just want to explain very quickly why inferential statistics matters. Say that we have an hypothetical study where our participants are adult smokers, and we are trying to compare two interventions. First, the new intervention, so a new smoking cessation therapy, for example, and the alternative intervention will be our usual care. The outcome we try to estimate will be the number of cigarettes per day. So we're trying to compare whether the number of cigarettes per day for the people in the intervention group versus people in the control group has changed during the study period. And the study period is 1 month. So we try to evaluate a change over 1. So let's also imagine that we measure the number of cigarettes per day for each participant at baseline. So that means at the beginning of the study. In particular, we calculate that the mean number of cigarettes per day is 12. This is for all the participants in our study. Now we know that a group of participants will be allocated to group A, which is the group receiving the new treatment or the new intervention, while another group of participants will be allocated to group B, people receiving usual care. Then at some point, after 1 month in particular, both groups are remeasured, and we know that, and we can calculate that the mean number of cigarettes for group A is now 9 per day, while the mean number of cigarettes for group B is now 10 per day. So in both groups, we see a reduction in the number of cigarettes smoked per day. So this reduction is a bit bigger for group A compared with group B. So what do we conclude? We can say that in these two groups, there is a strong reduction in the number of cigarettes smoked in group A. So it seems that in our sample of participants, the intervention is more effective than usual care. But in reality, we are not only interested in our sample of patients or in our sample of participants. Say that we have, in this particular case, a sample of, for example, 40 people. We are really not doing research just for understanding what's happening within the sample only. We are doing research in order to understand what is the effectiveness of an intervention when it's applied to the whole target population. For example, we can think the whole population of adult smokers in one particular city, in one particular region, or in one particular country. So we need to be able to infer, using inferential statistics, what might happen in our target population on the basis of what's happening in our sampling. And that's where inferential statistics comes into play. There are two main approaches available to answer this type of question. One is the estimation approach, which we are not going to look at today, and the other one is the hypothesis testing approach, which instead we will look at today. With hypothesis testing, we really trying to estimate the probability of how much our results were obtained by chance. So if I'm a researcher, I conduct a study with these participants, with adult smokers, I want to know the probability of how much my results were obtained by chance. So I observe a difference in the effectiveness of the two interventions. Was this difference driven by chance or not? As a researcher, I would like this probability to be quite small. We are dealing with a two-sample design. So we need to understand whether the samples come from populations that have the same central location. For example, the mean, the median, so on. If you're not familiar with the concept of mean, median, or other descriptive statistics, please have a look at our video on descriptive stats, which is available on the ARC West Coast YouTube channel. With hypothesis testing, we are essentially testing two hypotheses against each other. One is the null hypothesis. There's no difference between the groups, or, for example, there is no effect or there isn't any association. And the other one is the alternative hypothesis. The hypothesis we are really testing when we are doing research. For example, in this case, there is a difference between the groups, or we might want to test whether there is an effect, an association. With the hypothesis testing approach, we are testing these two hypotheses against each other, and we are trying to understand whether the difference we observe in our sample is driven by chance or not. So if we were to apply the intervention to the whole target population, would we be able to observe a difference between people receiving the new intervention and people receiving usual care? There are different statistical tests available in order to answer this question. And the way we decide which statistical test is the most appropriate in our particular situation is by considering the distribution of our variable. In this case, our variable is the number of cigarettes per day. What do I mean with distribution? A lot of things in real life follow the so-called normal or Gaussian distribution. Imagine that you collect the height of 1,000 people and you want to calculate the probability of measuring a certain height, okay? You will position all your height from smallest to highest on a horizontal axis, and then you try to understand how many people have that specific height. So you will have a few people with a small height, a few people with very big height, and a lot of people will be in the middle. In particular, a lot of people will have a height which is around the mean height of your sample. In this particular case, then, you will observe that the distribution of the probability of the different heights will be symmetric around the mean. So the mean represents the center of your distribution. And when you have a distribution which is symmetric around the mean, you will have a normal distribution. This is not only true for eyes, but it is true for other things in real life. For example, shoe sizes or blood pressure or birth weight. So there are a lot of things in real life that follow the normal distribution. Why does it matter for us? There are two sets of methods which we can use in inferential statistics. One set is the set of parametric methods, and the other set is the set of non-parametric methods. That means there are certain statistical tests which assume a distribution for your particular variable, and other statistical tests which do not assume a distribution for your particular variable. So understanding whether your variable follows a specific distribution will help you decide whether you need to adopt parametric or non-parametric methods. What are the key things to consider when you decide on a particular inferential test? First of all, population distribution. We just covered this a few seconds ago. So if you have a normal or symmetric distribution, we'll need to adopt parametric method or parametric test. If instead your population distribution is skewed, so you might have a lot of values which are very, very low, or a lot of values which are very, very high, that might happen, for example, for things like income, for example, then in this case, you will have to adopt non-parametric tests. Another key things to consider is the sample size. If you got a very large sample size, then it might be more suitable to adopt parametric method. In particular here, we need to mention the central limit theorem, which is one of the most important theorems in statistics. Central limit theorem is related to the sampling distribution of the sample means. So that means if you got a sample of 40 people, you will have a specific mean. If you take another sample of 40 people, you will have another mean. If you take a third sample of 40 people, you will have another mean. So if you take all these means from all these different samples, you can be able to create a sampling distribution of your sample mean. As you increase the size of your samples, the sampling distribution of the sample means will follow a normal distribution. In particular, as a rule of thumb, if your sample size is higher than 30, then the mean of your sample will follow a normal distribution. So for large sample size, it might be suitable to adopt a parametric test. For small sample size, on the other hand, it might be more suitable to adopt non-parametric. And third key thing to consider is the type of data you're dealing with. Again, this is something you can have a look at more detail by watching the video on descriptive statistics. There is a short part which covers the different types of data you might deal with in statistics. In particular, if your data is quantitative, then it might be more suitable to adopt parametric methods. On the other hand, if your data is ordinal or if you got skewed quantitative data, then non-parametric tests might be more suitable. In our example, so going back to our example, remember we had a two-sample design where we were trying to test whether the difference between the two groups were driven by chance or not. So we are dealing with quantitative data. If we believe that our sample data comes from a population with a probability distribution which is parametric, then it would make sense to apply parametric test. Particularly in our two-sample design, we would apply an independent samples or two-sample t-test. If instead we believe that the underlying probability distribution is non-parametric, then in that case we would apply a Mann-Whitney U-test. There are different tests available in the case of a one-sample design. So a one-sample design will be the case where you test the difference pre and post intervention on the same group of people. As you can see in the table, there are parametric and non-parametric tests available for the one sample design as well. Also, bear in mind that there are many statistical tests and techniques available out there. Here we list some of the most common, like the chi-square test, which provide information about an association between two categorical variables in the population, for example, two income groups. Analysis of variance when you want to compare the means from more than two groups. So you might have 3 interventions, for example, you are trying to investigate rather than 2. Correlation when you want to test the association between 2 continuous measures. For example, if you want to test the correlation between age and the number of cigarettes per day. And regression when you want to investigate the contribution of various factors to the result. So you're not only interested in the role played by the different interventions in changing the number of cigarettes per day, but you also want to test the role played by age, or the role played by gender, or the role played by pre-existing conditions in changing the number of cigarettes per day at the end of the study period. As a final note, remember that in this video, we focus on hypothesis testing, which typically leads to the measurement of a p-value. With the estimation approach, instead, you usually will obtain a confidence interval around a specific estimate. Confidence intervals and p-values are other very common statistical concepts which we'll look in more detail in another video. But today we just focus on providing an intro to inferential statistics, why it matters, how do we choose the different methods available, and what are the common inferential tests available. Thank you for your attention.